In the last video, we discussed about reflection of light. That is, the bouncing back of light from a highly or polished, very smooth surface. That bouncing back of light is known as reflection of light. And we discussed about mirror formulae, and various ray diagrams in connection with the concave mirror and convex mirror, both we discussed. And here we will discuss about refraction of light. Refraction of light. So this phenomenon about a refraction of light already you might have studied. You have studied in 10th and you have seen various observations also. If a stick, if it is in water, if it is lying obliquely, you can see that if there is a bend in the stick. All these are because of refraction of light. So what is meant by refraction? Refraction means the bending of light. Bending of light as it travels from one medium to another. Bending of light. So, whenever light travels from one medium to another, it bends. Why it is bending? Because in each medium, the speed of light will be different, because of which, as it travels from one medium to another medium, it will bend. Even though it bends, after it bends, it will travel to a straight line. Is it clear? So, whenever refraction is taking place, after obeying, or it obeys certain laws of refraction. So which are those laws that we will see first? Laws of refraction of light. The first law is similar to that of reflection of light, but it is the incident ray. The incident ray, the refracted ray, and the normal at the point of incidence. Normal at the point of incidence. Lie on the same. The first one says that incident ray, refracted ray and normal at the point of incidence lie on the same. So what is meant by incident, refracted and normal? That we should know. So we are considering light is travelling from one medium, to another medium, and if it is bending like this. So this ray, we will say it as incident ray. The ray which is incident on the surface, that we will say it as incident ray, and the ray which is refracted to the second medium, that we will say it as refracted ray, and this angle we will say it as angle of incidence, and this is angle of refraction, and this is the normal. So angle between the normal and incident ray is angle of incidence, and angle between normal and refracted ray is angle of refraction. So what first law says? The incident ray, the normal and refracted ray all are lying in a plane. And second law, what it says is that the ratio of sine of angle of incidence, sine of angle of incidence is constant. Is constant for a given pair of medium and for a given color of light and for a given color of light and is known as refractive index of second medium. Refractive index of second medium with respect to first medium. Refractive index of second medium with respect to first medium. Even though it seems to be lengthy, it is very simple. We can write how ratio of sine of angle of incidence. So sine is sine of angle of incidence, and what is ratio of sine of angle of incidence to sine of angle of refraction, and that is constant. No, constant means we can write a constant, and here constant we are writing it as a refractive index of second medium with respect to first medium. We are writing it as n/1, and this we will read it as refractive index of second medium with respect to first medium. Okay, is it clear? And now we will discuss about what is meant by this refractive index. You should know. Refractive index or absolute refractive index. Absolute refractive index of a medium is known as the absolute refractive index. We are representing it as L, and that is defined as the speed of light in vacuum or velocity of light in vacuum to velocity of light in that medium. Okay. Speed of light in vacuum to speed of light in medium. And what's the speed of light in vacuum? That is given by 3 into 10 raised to 8. So in problems you can write it as 3 into 10 raised to 8 meter per second. And speed of light in medium we will write it as V. Or normally we will write it as refractive index is equal to C by V, where C is the speed of light in vacuum. Okay. Speed of light in vacuum, we are writing it as N is equal to C by V, where C is equal to 3 into 10 raised to 8 meter per second. Okay. And now we will discuss about refraction of light through a prism. Refraction of light through a glass. So before discussing that, we we will discuss about refraction of light itself. So depending on the value of refractive index, we can classify material as lesser denser medium and rarer medium. Okay, rarer medium and denser medium. So rarer medium and denser medium, it depends on the value of the refractive index. It depends only on the value of refractive index. It is not related with our mass density. It depends only on the value of refractive index. So if refractive index, for example, for water, the refractive index is 1.33, and for glass, the refractive index value is given by 1.5, and for diamond, the refractive index is 2.4. Okay, so for water, refractive index is given by 1.33, for glass, refractive index value is given by 1.5, and for diamond is 2.4. Different values are given in the table. In textbook one table is there. You can go through that table. No need to bypass the values. At least this water and glass you can do. Okay. For air it is 1.00. Okay. We will consider it as 1. So we can see from these three we can say that diamond is having more refractive index. So we will say that diamond is denser than glass. Okay. Diamond is denser than glass. Similarly, if we are considering glass, we can say that glass is denser than water but rarer than diamond. Why? Because refractive index of glass is more than water. So we will say that glass is optically denser than water, but it is optically rarer than diamond because its refractive index is lesser than water. Okay. So by comparing two only we can say that whether it is optically denser or rarer. If only one it is given, we cannot say that whether it is denser or rarer. Okay. And when light is traveling from rarer to denser medium, rarer to denser medium, light is traveling from rarer to denser medium optically. So rarer medium means less denser to more denser, whichever having less refractive index to more refractive index. For example, air to water. Light is traveling from air to water. So what happens? Here we are considering this is our incident ray. So when it is incident on the interface, no doubt it will be bent. It will be refracted. No? So the it will be refracted in such a way that angle of incidence will be more than angle of refraction. Or we can say that it will bend towards the normal. Okay? So we can write if a ray is traveling from rarer to denser medium, rarer to denser medium. If a ray is traveling from rarer to denser medium, it will bend. It bends towards the normal. Or in other words, we can write angle of incidence will be greater than angle of refraction. Okay. So this is the case of light travels from rarer to denser medium. If vice versa happens, means if it is traveling from denser to rarer medium, so our denser medium is here, rarer medium, denser to rarer. Okay. So here light is incident. What happens? It will bend away from the normal, which means angle of incidence will be less than angle of refraction. Okay. we can write here, when light travels from denser to rarer, it bends away from the normal, or we can write it bends away from the normal, or we can write angle of incidence will be less than angle of refraction. Okay, is it clear? So this is about refraction. Okay, when light travels from denser to rarer and rarer to denser. And now we will discuss about refraction of light through a glass slab. Okay, refraction of light through a glass slab. Refraction of light through a glass slab. Okay, so here we are considering a glass slab. Let T is the thickness of the glass slab. T stands for the thickness. Okay. Let T is the thickness of the glass slab. Okay. So if a ray of light, here we are drawing perpendicular first. Okay. We can draw normal. So a ray of light is incident. So this PQ is our incident ray. It is incident at an angle theta. So what will happen to that ray? It is traveling from rarer to denser medium. So it will bend towards the north. It bends towards the north. Again, when it reaches here, what happens? It is traveling from denser to rarer medium. No? So it will bend away from the north. So this we will say PQ is the incident ray. We can write here PQ is the incident ray and QR is the refracted ray through the glass slab. Refracted ray through the glass slab. And RS is the emergent ray. We will call it as emergent ray. Why we will say it as emergent ray? Because it is coming out of the glass slab. It is also a refracted ray only, but since it is coming out of the glass slab, we will say it as emergent ray. And I is the angle of incidence, and this is angle of refraction. We can write it as R. We can mark it here. I, angle of incidence. R, angle of refraction. And this angle, the angle made by the emergent ray with the normal, this we will say it as angle of emergence. E, angle of emergence. Okay. So the diagram is clear. No? Incident PQ is the incident ray, QR is the refracted ray through the glass slab, and RS is the emergent ray. I is the angle of incidence, angle made by the incident ray with the normal. Again, angle made by the refracted ray with the normal is angle of refraction, and this is angle of emergence. Okay. So if you extend this incident ray, you can see that. You can extend this. Okay. You can see that this emergent ray and extended incident ray are parallel. It is clear from the diagram, no? If you extend this incident ray, you can see that its extended incident ray and emergent ray are parallel. Or in other words, we can say that if you measure this angle of emergence, you can see that angle of emergence equal to angle of incidence. Okay. So, which are the observations? The extended incident ray is parallel to the emergent ray. The extended incident ray is parallel to the emergent ray, and or in other words we can write the angle of emergence equal to the angle of incidence. All of you did this activity, no? You may be remembering what you did in 10th. Okay, so you can do this activity also. So that we can say that angle of emergence is equal to angle of incidence, or we can write I is equal to angle of incidence is equal to angle of emergence. Now the perpendicular distance, that also you have studied. The perpendicular distance between the extended incident ray and the emergent ray, this perpendicular distance is known as, what it is, this RT perpendicular distance is known as lateral displacement or lateral shift. What is lateral shift? The perpendicular distance between the extended incident ray and the emergent ray. Is known as lateral displacement or lateral shift. Lateral displacement or lateral shift. Okay, lateral displacement or lateral shift. So here we can find an expression for the lateral displacement or lateral shift. How to find? We can consider the triangle. We can start this triangle first. We'll complete it. Draw this perpendicular. So you can consider the triangle QRU. So we have to find an expression for RT. So here lateral shift is given by RT. Okay. So we have to find an expression for RT in terms of I and all those quantities given. Okay. Is it clear? We have to find that, we will find it now. Okay. So we can consider the triangle QUR. Okay. From triangle QUR. So our aim is to find an expression for RT in terms of the known quantity thickness of the glass slab and I and R. Okay. So from this triangle QUR, we can write what it is, QU by QR is equal to cos R. And we write QU is the adjacent side, QR is the hypotenuse, that is equal to cos R. Or we can write QR is equal to QU by cos R. And what is QU? QU is the thickness of the glass slab. So that already we mentioned T by cos R. That can be written as TCR. Okay, is it clear? Now again we can consider the triangle QRP. We are considering the triangle QRT. Okay. So what is this angle? This angle, total angle is I, this angle is R. So we can write it as this angle as I minus R. Can we write? Can we write? Because total angle is this, vertically opposite angle should be equal. So this angle should be equal to this angle. So this angle is R. So remaining angle will be I minus R. So consider the triangle QRT. From triangle QRT, but we can write QRT. This angle is 90 degree. No. So we can write sin I minus R is equal to RT by QR. Can we write? QR, for this it is the hypotenuse. So we can write sin I minus R is equal to RT by QR. What we have to find? We have to find RT. No? So we can write RT is equal to QR into sin I minus R, and RT is the lateral shift or lateral displacement. So we can write lateral shift is equal to QR. What is QR? We put it as T sec. So lateral shift is equal to T sec into sin. So by using this we can find the lateral shift, where T is the thickness of the glass slab, R is the angle of refraction, and I is the angle of incidence. So we can see that as thickness increases, okay, as thickness increases, what happens to the lateral shift? Lateral shift also increases. Is it clear? Understood? No? So this is about refraction of light through a glass slab. So today we discussed about what is meant by refraction and what are the laws of refraction. Among that, Snell's law of refraction, that is very important. Second law, that is Snell's law of refraction. Then we discussed about what will happen if light travels from denser to rarer and rarer to denser medium. Finally, we discussed about the refraction of light through a glass and got an expression for the lateral shift. This is very important. You should know this. Okay, lateral shift is equal to T sec into sin I minus R. I hope all of you understood it. If you are having any doubt, you can contact me. Okay.